This is part 2 of a projectile motion question. What happened was we had a piece of string which had a natural length of 0.4 meters and its modulus of elasticity was 10 newtons. Now the string had been stretched, it's been projected up, and it stopped at a position 0.3 meters below where it's fixed. Now what it will do from here is it's going to fall, and as it falls it's going to then stop at some stretched position, and the objective is to find out how far will this extension be. So what will the stretch become? Now what we'll do is we'll look at our two positions. We'll look at this position here at the top of the height and this position here at the far lower end where it stops. This is the kinetic energy. We already know the kinetic energy here will be half times, oh by the way the mass was 0.5 kilograms. So we know that it's going to be half mass v squared. It's going to be stopped at the bottom. Now its potential energy at the bottom will also be 0 because it's mass times 10 times our height, which is now 0. It's used up every height. The thing is, there's going to be an elastic potential energy in the system. We just don't know what that stretch is going to be. So the stretch in this case we'll say is x, so it's going to be 10 lambda over 2 times L, so 2 times 0.4 times that stretch squared. Now this summation here is the full energy at the base, and so the sum energy at the base is simply going to be 2 divided by 0.8, 10 divided by 0.8, so that's 12.5. So that's going to be 12.5 x squared. Let's have a look at the sum at the top. Let's change this. Let's get a different color for this sum at the top. Now the kinetic energy at the top is also 0 because it's just stopped momentarily to turn around and head back down. So the kinetic energy is 0. The potential energy though is at the top of its height. So mass is 0.5, gravity is 10. Now here the height, it's going to drop 1.1 meter before its natural length, and then the x. So it's going to drop 0.1 meters plus that x, which is the stretch factor. And its elastic potential energy is also 0 because there's no stretch. So the sum in this system is simply the 55 times 0.1 plus x. And we'll just say 0.5 plus 5x. Therefore, the sum at the top will equal the sum at the bottom, so we can equate these to be 0.5 plus 5x equals, and that's 12.5 x squared. Now get everything to one side, and we will say 0 equals 12.5 x squared minus 5x minus 0.5. Therefore x will equal negative b, so 5, plus and minus b squared, which is 5 squared, minus 4 times a times, that's 50, times c, negative 0.5. So that becomes 25 minus negative 25, that's all 25 plus 25 under there, all over 2a, which is 2 times 12.5, so 25. So we've got x equals 5 plus and minus square root of 50 all over 25. Put that in your calculator and you'll get a value of 0.483 meters, and that's the stretch that you will get. Hope this has helped. Until I help you again, stay happy.